invention of paper in ancient China around 105 AD revolutionized how information was spread. Centuries later, the printing press, or what we might call 2D printing, continues to transform our world. Now we're experiencing a new shift where 3D printing continues to change the way we build and design objects. In this video, we're going to look at some incredible ways 3D printing is shaping our world and may change it forever. My name's Farhan. I've been a product design engineer for many years. I've worked at Apple and Google, and now I'm the CTO of a startup. You should see how many things I 3D print. In fact, I have some things here on my desk right now. For example, this bracket and this little lever arm that, fit together nicely and worked in some sort of function to do something, right? In the robotic basketball machine that I'm building. And even this little pen that I designed for a project I'm doing called Side Note. In this video, we're going to talk about 10 different forms of 3D printing that I think you should know about, and it can help you become a better engineer and a better designer, and honestly just learn about how the world is changing for the better. We're going to talk about FDM first, fused deposition modeling. This is where an extruder, or a hot end it's called, of a 3D printer heats up very hot and squeezes plastic through it, and creating this spaghetti-like shape and structure, layer by layer, building up the project or the part that you're building. And it works very nicely because it's what's known as additive manufacturing, where you're kind of adding layer by layer, adding material to create this form and structure. Just a quick note, on the screen, you'll see something called CNC. It's called subtractive design or subtractive manufacturing, where you're taking away material. And that's one of the more normal ways of manufacturing things, where you start to cut away things, cutting out of wood or metal. But additive manufacturing works a bit differently, where you add layer by layer. And in this example, you can see on the screen where the machine, it's coming and it's adding that plastic layer one by one, like a spaghetti-like shape, up and down until it creates this full product. It's very interesting. So that's fused deposition modeling. What would you use it for? Well, FDM has some limitations, and it's specifically in the kind of material that you're using and the speed of manufacturing. FDM, unfortunately, is quite slow to manufacture. In fact, this part, for example, took about 1 hour to print. And that's quite a long time for just something this small, right? Even with the most optimized settings. And so consider FDM for prototyping at home, especially if you can wait the long time to prototype. However, what it's good at is it's very cheap, and it's been around for so long that you can build, basically, you can have your own 3D printer for under $100, even within $50. You can buy some really cheap, nice printers. But the nice thing is it's super accessible and anyone can do it. And it's actually known as a hobby grade kind of printing technology. You'll find many ways to tinker and build a better printer, even from the $50 one. So I do recommend learning about FDM, using some of those printers and building some models such as this in your own home. Some materials that you can consider for FDM include PLA, ABS, and PETG. You can also print nylons and more advanced materials, and it's very versatile. That's the point. And mainly thermoplastics, any kind of plastic, if you can melt it down, you can most likely print with it, especially lower temperature around 200 degrees Celsius. You can print with FDM printing. So if you're okay with using plastics, FDM is a great option. And if you want something cheap and quick and you can just have in your own home, FDM is the way to go. Next, we're going to talk about SLS, selective laser sintering. Now, this is a very interesting and more modern approach to 3D printing. It works by shining a laser light in this vat of resin, it's called, where the laser light cures this liquid resin into the form and shape of the part. And it does so by tracing the outline of the part, kind of like FDM, where you're building this layer, building all of these parts one by one together until you form the final part in one. It's an incredible way to 3D print because the kind of detail and resolution you can get on the parts are phenomenal. They can even be as good as, or almost as good as, production parts, and you can barely see the layer lines. In fact, I've used SLS to create some lenses, and even optically clear lenses that just with a little bit of polishing work as a lens. And so SLS is a great tool, especially for scientific models and even production-ready, customer-facing, high-quality cosmetic parts. So SLS is something you should look into. Some of the drawbacks include it takes a long time to print with SLS, even longer than FDM sometimes. The resin material can be very expensive. You also waste a lot because when you pour it in, when you pull out the part from the resin vat, a lot of it drips off. You lose a lot just in the manufacturing of it, and so it is something a bit more costly. One other thing to think about when you use SLS is that it's actually pretty messy and hard to work with and a bit hazardous. You need to wear gloves, you need to wear a mask, and so handling an SLS print is much more difficult than an FDM, where you can just pop it off the build plate right after it's done and start using it. So keep that in mind. So the next 3D printing technology we're going to talk about is DLP, digital light processing. It's very similar to SLS, but instead of going around and tracing the outline of the part, what it does is it actually shines a UV light for the entire layer all at once. And how this is different is you basically print an entire layer at a time, instead of printing the outline of the layer one by one. This vastly improves the speed. However, the resolution and the detail of this printing method is dependent on the light that's being shined. And actually the way that this works is you have an LCD screen that blocks light. And so an LCD screen has pixels. And so if you have a high resolution LCD display that's blocking the light, you'll have a much better print at the end, right? And because of this, the higher cost machines generally have higher resolution. And so cost can be an issue here, especially if you want super high resolution. But recently, these type of printers have become much more accessible, much easier to print with, and that's because the technology for these LCD displays has become much more available for mass production. So similar to SLS, the similar kind of materials can be used, similar kind of problems. So the DLP is more accessible to you now, but remember that it's hard to clean, it's hard to work with, and it's pretty expensive, the resin itself. So I recommend considering a higher budget if you're going to use this, and having a processing station or a processing room, a well-ventilated area where the fumes can get out really easily and you can work with this material more easily and safely. Next, we're going to talk about metal 3D printing, and metal 3D printing is pretty awesome. There's a few ways to do it, and we're going to talk about a few of them, but it does create some amazing parts. It will revolutionize manufacturing, especially as we get to faster and faster metal production times. What's awesome about this printing method is you can work with more organic shapes that can be better for the part. For example, bicycle frames, drones, and such, where you don't need to worry about when a machine comes and has to cut out these shapes in specific axes. This 3D printed shape can be very organic. And as a result, 3D printing metal has become much more popular in recent years. It's still slow, and so mass production is hard to do with metal 3D printing, but for building prototypes, for building organic shapes, for building one-offs, or even low volume production, it is an amazing tool. How metal 3D printing works is really interesting. There's a vat of powder that is a metal powder, and the laser light is shined and it melts the metal particles together, creating a layer of metal that is molten and fused together as the laser light passes. So it's similar to SLS, where the resin is cured as each layer is made, but the metal is cured instead, or the metal is fused instead. So as I was alluding to before, this production method is really interesting because you can use it in manufactured parts, in automotive, in aerospace, anything that has high strength that needs to be basically representative of what you're trying to build. It's a great tool to use, metal 3D printing. But of course, you can imagine it's very expensive to use this, and this is because mainly it takes a lot of time to actually print with this, and the machine itself is very costly, so you're paying for the time and the price of the machine. And so keep that in mind if you're designing a part that you intend to be 3D printed out of metal, that it could be costly, and perhaps if there's an alternative to perhaps using CNC'd, or perhaps using a plastic part in the meantime, you can go for that instead. Polyjet is one technique I've used very extensively, and it's really, really amazing. It works by suspending these tiny droplets of UV curable resin that is also cured using UV light, similar to DLP, but instead tiny droplets are put onto the build plate rather than having this big vat of resin. And so as a result, you get these really, really beautifully intricate parts, very true to final design, true to cosmetics. In fact, you can even have colored 3D printed parts, which is incredible. So it's kind of having like a 2D printer, a normal printer that can print in color. It suspends those ink droplets onto the page, and you can print in color, or print your photographs in color, or print like documents in color. It's similar to that, where you can have 3D printed ink that has color on it, and it can be cured with that color in the right position and create these beautiful parts, as you can see on the screen. So this is used for making true to form cosmetic prototypes, and I've used that a lot to show to designers, show to like higher level executives who want to make final decisions on form and function. And this kind of 3D printing method is very much used in those situations. One of the drawbacks here is that the material generally is a little brittle. I found that it does break pretty easily, but you have more flexibility from the type of materials you can use, from transparent to rubber-like to more tougher or shatter-resistant ones to more functional prints. But in general, what I did find is that these are a lot more brittle. Even if they're rubbery, they do crack pretty easily. They can't really take a high load. So I do recommend you keep that in mind if you're printing with this kind of technology. Additionally, Polyjet can be quite expensive, so consider that when you're making your prototypes. All right, next is binder jetting. This one's a very interesting one. It's kind of like an inverse in some ways. So how this works is essentially you have this powdered vat and you have this head that has a liquid on it that deposits a layer of liquid that binds this material together. And it's quite interesting how it works. And you can see on the screen that binder jetting is very complicated, but it produces some really beautiful parts. And just like Polyjet, it has the capability to print in multiple colors at the same time and has the ability to create highly cosmetic prototypes as well. So what's also really amazing about this printing method is that you don't really need supports. And so you have this final prototype without needing to trim away supports, creating any kind of blemishes, trimming away that kind of support. So it's a great tool, a great way to print, and I do recommend you use it for highly cosmetic parts. Continuous fiber 3D printing. Now, this is one of the most excellent engineering type of printing methods that you can use. And it's basically printing normally like FDM, but in between some layers, you deposit a continuous fiber of, either fiberglass or carbon fiber or something else to create a composite structure. And what's amazing about this is that parts can be almost as strong as aluminum. You can see some demos in this video there, and they're literally just plastic, like made out of nylon, but it has some sort of carbon fiber layer, several layers of carbon fiber in it that creates this almost indestructible material, right? Especially for its function. And so if you need some really functional, amazingly strong parts that are intricate and designed, more organically than a regular CNC part, and you need it to be pretty quick and built right, right in your garage, this kind of continuous fiber 3D printing method is definitely the way to go. And the one that I use is Markforged. It's probably the best one on the market. Actually, I don't know if there's any other ones because they hold a patent for it, but it is really an incredible, the Markforged is an incredible printer, and it barely fails, and I do recommend it. However, it's still quite expensive. I don't have it personally, we have it through our company, but if you can grab a hold of one, and if you need to build very high intensity engineering parts, it's definitely the way to go. So that's Markforged and continuous fiber printing. It's very interesting and very amazing as well. All right, let's talk about some futuristic 3D printing methods. And these are really, really interesting. They're up and coming, and we don't really have desktop ones yet that we can just have in our own home, but they are emerging. And if you're interested in building technologies for 3D printing, these are some things to maybe inspire you to build things in your own domain. So let's start off with bioprinting. So literally bioprinting works by depositing layers of living cells one by one. And it's very interesting because people use this kind of printing method to help build organs. That's one of the goals, is how can we really 3D print and recreate a heart or a kidney for someone who's lost it. Because one of the issues of being able to give someone an organ transplant is you need to find a donor. And imagine printing an entire kidney from scratch, right? That is incredible. And bioprinting can be amazing for the medical industry because it can literally solve that problem of needing to build cells and tissue and organs for patients that need it. Next is volumetric 3D printing, or also known as Voxels. This is a pretty new 3D printing method, and how it works is it basically prints the entire 3D volume all at once. So what do I mean by that? Well, you know how we were talking about how 3D printing is generally layer by layer? So this method works by projecting light in a 3D pattern all at once, printing the entire 3D shape all at once. And you can print basically an entire object in seconds rather than hours. And so take a look at this video. It is incredible how fast this printing method works. And this will definitely revolutionize manufacturing, especially in the polymer space. Keep a lookout for that, because once this becomes mainstream in the market, manufacturing will change forever. So we have 2D printing, right? Or normal printing, where you're printing letters on a page. Then we have 3D printing, right? Where we're printing things in 3 dimensions. But what if I told you there's a 4th dimension printing? It's not really printing in time though, or something like that. Actually, the 4th dimensional printing works by printing an object that will take another characteristic once the printing is complete. For instance, in the examples you can see here, the object that is printed will take on more movement after it's printed. This is very useful for robotics and automotive applications where you need the object to kind of move after the fact. And so for example, let's just say you want to build a crawling robot that needs to crawl inside a pipe. Having a part that can deform and deflect in a predictable manner is very key here, where you want it to move and crawl through these small spaces. So 4D printing is very interesting. Thinking about how you can have the motion of the object in mind as you print is very interesting. And finally, as we end this journey of 3D printing, let's talk about nanoscale printing. We work a lot in the nanoscale today, especially when we're building microprocessors and chips. You might have heard about nanometer technology in your chips, like say the M1 chip on the MacBook. Now, what does that mean? Well, chips are made on the nanoscale because you have transistors that have to be so small, and they're basically little switches that are invisible to us, right? They're atomic scale. Well, what about nano 3D printing? Imagine you can print these chips or print 3D objects that are the size of nanometers, right? Instead of millimeters. Why would scientists want to do this? Well, what if you wanted to build a robot that is the size of a white blood cell? Imagine you have a pathogen in your body and you need some help. Printing in the nanoscale will allow you to build a 3D printed robot that is the size of a white blood cell that can go defend your body against this pathogen. Imagine hundreds of these nanobots inside your body defending you from parasites or different illnesses, even eliminating cancer cells right at the source. So nanoprinting is becoming something really big, and I do recommend you learn more about it, because as you learn more about nanoprinting and you find out the applications, you'll know how it's going to change your life, especially in the medical field, even in military, even in aerospace. Being able to print things that are so small and mobile and robotic will revolutionize the world. So there you have it. 3D printing is really incredible. There are so many ways that we're building things from scratch, right? Building 3D objects in space. And we've come a long way, from etching down numbers and words and letters and figures on stones and paper, to the development of the printing press, where we can fabricate thousands of papers a day, where we can distribute knowledge and information across the world, right? And then next, in the material world, 3D printing has emerged, where we are able to create 3D printed objects even in your home. Imagine one day being able to print your car in your garage, right? You're like, hey, I want to build a Lamborghini in my garage. You might be able to do that someday soon, right? And so 3D printing is becoming this synonymous technology in our world. I hope you enjoyed the video. Please share some 3D printed projects that you've worked on. I'd love to see them. In the meantime, you can watch this video to learn more about engineering in general. And if you're interested in business and technology and how they merge together, you can watch this video. Thanks again. I'll see you in the next video. Take care.